Hi, this is David Voss, CCIE 11372, and in this video you're going to learn about ISIS design. Specifically, you're going to learn about ISIS operations, areas, addressing, packet types, network types, and metrics. So let's begin. In recent years, the ISIS routing protocol has become increasingly popular, with widespread usage among service providers. It is also a very flexible protocol that's been extended to incorporate leading-edge features such as MPLS traffic engineering. The ISIS routing protocol is a link state protocol as opposed to distance vector protocols such as RGRP and RIP. ISIS protocol is an intra-domain OSI dynamic routing protocol. ISIS uses a two-level hierarchy, and it's used to support these large routing domains. A large domain may be administratively divided into areas. From a high level, ISIS operates as follows. Routers running ISIS will send hello packets out all ISIS-enabled interfaces to discovered neighbors and establish adjacencies. Routers sharing a common data link will become neighbors if their hello packets contain information that meets the criteria for forming an adjacency. Routers may build a link state packet LSP based on their local interfaces that are configured for ISIS and prefixes learned from other adjacent routers. And a shortest path tree is calculated by each IS, and from this SPT, the routing table is built. Next, let's talk about areas and the routing domain within ISIS. So an ISIS routing domain is similar to BGP autonomous system. A routing domain is a collection of areas under an administration that implements routing policies within the domain. First, let's talk about the backbone. ISIS does not have a backbone area like OSPF Area 0. The ISIS backbone is a contiguous collection of level 2 capable routers, each of which can be in a different area. Now, speaking of areas, within ISIS, an individual router is only in one area, and the border between areas on the link that connects the two routers that are in different areas. And the border between areas is on the link that connects two routers that are in different areas. This obviously is in contrast to OSPF. So as you've already heard, ISIS has a two-level hierarchy. Contiguous level 2 capable routers from the backbone. Both level 2 and level 1 routers live in areas. Routers can be level 1, level 2, or both level 1, level 2. Within the Cisco iOS software, the default configuration is both level 1 and level 2 at the same time. This allows ISIS network to run with minimal configuration in more of a plug-and-play fashion. Level 2 capable routers connect all areas within a routing domain. Level 2 routers advertise their own NSAP address to other level 2 routers in the backbone. And all level 1 routers and hosts in an area must have an NSAP with the same area address. A level 2 router may have neighbors in the same or in different areas, but it has a level 2 link state database with all information for inter-area routing. Level 2 routers know about other areas but will not have level 1 information from its own area. A level 1 and level 2 router may have neighbors in any area. It has two link state databases, a level 1 link state database for intra-area routing, and a level 2 link state database for inter-area routing. Next, let's talk about NSAP addresses. An NSAP describes an attachment to a particular service at the network layer of a node, similar to the combination of IP destination and IP protocol number in an IP packet. An NSAP address has two major parts: the IDP, or initial domain part, and the DSP, the domain-specific part. The IDP consists of a 1-byte authority and format identifier, that's the AFI, and a variable length initial domain identifier, the IDI. And the DSP is a string of digits identifying a particular transport implementation of a specified AFI authority. Everything to the left of the system ID can be thought of as the area address of a network node. The big difference between NSTAP style addressing and IP style addressing is that in general, there will be a single NSTAP address for the entire router. All ISs and ESs in a routing domain must have system IDs of the same length. All routers in an area must have the same area address. All level 2 routers must have a unique system ID domain-wide, and all level 1 routers must have a unique system ID area-wide. All ESs in an area will form an adjacency with a level 1 router on a shared media segment if they share the same area address. If multiple nets are configured on the same router, they must all have the same system ID. Next, let's talk about packet types. There are 4 types of packets. Each type can be level 1 or level 2. First, there is the intermediate system to intermediate system hello packet used by routers to detect neighbors and form adjacencies. Then there's the link state packet. There are 4 types of LSPs: level 1 pseudonode, level 1 non-pseudonode, level 2 pseudonode, and level 2 non-pseudonode. Complete sequence number PDU. CSNPs contain a list of all LSPs in the current database. CNSPs are used to inform other routers of LSPs that may be outdated or missing from their own database. This ensures all routers have the same information and are synchronized. And then finally, partial sequence number PDU. PSNPs are used to request an LSP and acknowledge receipt of an LSP. Next, let's talk about network types. The types of networks that ISIS defines include point-to-point and broadcast networks. Point-to-point networks, such as serial lines, connect a single pair of routers. A router running ISIS will form an adjacency with the neighbor on the other side of a point-to-point interface automatically. The DIS is not elected on this type of link. The basic mechanism defined in the standard is that each side of a point-to-point link declares the other side to be reachable if a hello packet is received from it. Next, there's broadcast networks such as Ethernet, even token ring. These are multi-access and they are able to connect more than 2 devices. All connected routers will receive a packet sent by one router. On broadcast networks, one IS will elect itself the DIS. The DIS is responsible for flooding, and it will create and flood a new pseudonode LSP for each routing level that it is participating in, that is level 1 or level 2, and for each LAN to which it is configured and connected. A router can be the DIS for all connected LANs or a subset of connected LANs, depending on the configured priority, or if no priority is configured, the layer to address. And then finally, NBMA networks such as Frame Relay or ATM or X25 can connect multiple devices but have no broadcast capability. All other routers attached to the network will not receive a packet sent by this router. Special considerations need to be taken in account when configuring ISIS over these types of networks, because ISIS considers these media to be just like any other broadcast media such as Ethernet or token ring. In general, it is better to configure point-to-point networks on WAN interfaces and sub-interfaces. Next, let's talk about ISIS metrics. Cost is the default metric. It is supported by all routers. While some routing protocols calculate the link metric automatically based on bandwidth, such as OSPF, or bandwidth and delay, such as EIGRP, there is no automatic calculation for ISIS. Using old-styled metrics, an interface cost is between 1 and 63. All links use the metric of 10 by default. The total cost to a destination is the sum of all costs on an outgoing interface along a particular path from the source to the destination, and least cost paths are preferred. The total path metric was limited to 1023. This small metric value proved insufficient for large networks and provided too little granularity for new features. The Cisco iOS software addresses this issue with the support of a 24-bit metric field, the so-called wide metric. Now metrics can have a maximum value of, as you can see right here. Deploying ISIS on the IP network with wide metrics is recommended to enable finer granularity and to support future applications such as traffic engineering. So you have learned quite a bit about ISIS. You've learned about ISIS areas and router types, the NSAP address, as well as packet types, network types, and metrics. All this information will be needed on your CCDA exam, and I'm confident if you've studied this video well, you're going to do very well on your exam. Good luck in your studies.